I have a question.
Sure.
So, you know how we didn't have the semester test last year?
Uh-huh.
Will we still have them this year?
Yeah.
I
That's
mean, we'll
the
have them like this semester,
that's the plan. It's not set in stone.
and will everybody have to take it this semester?
No.
Okay.
If we do have them, it'll be the um, exemption policy that we've had in the past, like absences and grades go into play.
How many absences is that?
It depends on what your grade is in the class and whether it's a first, second, or third block class or a fourth and fifth block class. I don't remember all the rules.
Wow.
It's in the handbook. Okay, set operations and compound inequalities. We're going to write some definitions. Okay, I'll let y'all get caught up and then we'll talk about what the union of two sets is. Okay, the union of two sets is defined with the word or. For any two sets A and B, the union of A and B symbolized A, this U symbol should be pretty easy to remember. This U symbol stands for union. B is defined as, okay, the best way I think to explain it is with a Venn diagram. So if we have a Venn diagram, and this is all the elements that are in set A, this is all the elements that are in set B, the union of A and B includes all of this. It's not just the numbers that they have in common, it's all the numbers. Any number that's, if it's only in set A, it doesn't matter, it's in the union. If it's only in set B, it's still in the union. Let's look at an example. Okay, example 1, set A has the numbers 1, 2, 3, and 4. Set B has the numbers 2, 4, and 6. And we're asked to find A union B. So the union of A and B is all the numbers. We're not going to repeat numbers though. So I know that we have 1, 2, 3, and 4. And then out of set B, we're not going to repeat the 2 and the 4, but we do need to include this 6. So the union is going to be 1, 2, 3, 4, and 6. Okay, another quick definition. Take a second and get this definition copied down. A compound inequality consists of 2 or more inequalities linked by a connective word such as and or. So today we're going to look at compound inequalities that use the word or, and we're going to look at the steps for solving that. Steps for solving a compound inequality with or. The first step is going to be to solve each inequality individually. After you solve each inequality individually, you have your solution. You just have to think about what the inequalities mean and what your solution is going to look like. And the solution set will include all elements that satisfy at least one of the inequalities. We'll say numbers. The solution set will include all numbers. Solution set will include all numbers that satisfy at least one of the inequalities. All right, let's look at an example. This will be example 2 for this set of notes. Six x minus 4 is less than 2x, or negative 3x is less than or equal to negative 9. We're going to solve these inequalities the same way we've been solving. So let's work the first one first. We want all the x terms on the same side. So I'm going to subtract 2x from both sides. But then that means I'm going to want to get rid of this minus 4. So I'm going to go ahead and do that in this step as well by adding 4 to both sides. Yes. Yes. So 6x minus 2x is 4x. These 4's cancel. The 2x's cancel. We're adding 4 to nothing. So 0 plus 4 is 4. And then we want to get x by itself, so we'll divide both sides by 4. We get x is less than 1. Solving the other inequality, all we need to do to get x by itself is to divide both sides by negative 3. So we're left with x on the left side, and because we're dividing by a negative, our sign flips. And then negative 9 divided by negative 3 is positive 3. So we've solved both the inequalities. We're going to write our solution in interval notation, and we're also going to draw a graph. So we're going to show our solution on a number line as well. And I think that drawing the graph first actually helps you write the interval notation. So let's draw the number line first. On our number line, we're going to have a 1 and a 3. You have to look to see if you're going to have an open circle or a closed circle. This inequality is x is strictly less than 1. There's not a line underneath. That means x could also equal 1. So because it's strictly less than, at 1, we have an open circle. Our other inequality, x is greater than or equal to 3. Because x could also be equal to 3, we have a closed circle at 3. Okay, then we're also going to have some shading. So x is less than 1. That means x could be these numbers that are less than 1, anything less than 1. So we're going to go all the way out to negative infinity. We draw our arrow to show that. And then x is greater than or equal to 3. We've shown that it could be equal to 3 with the closed circle, but x can also be greater than 3. So that's all the numbers to the right, these numbers that are greater than 3, all the way out to positive infinity. Okay, to write our interval notation for our solution, we have two different intervals that we've got to represent. So when we write our two intervals, we're going to join the intervals with that U shape, the U that stands for the union. So let's focus on this first interval. This first interval is from negative infinity up to 1, and we're not including 1 because it's an open circle, so we're using a parenthesis with 1. Then we're going to write our other interval. So we're going to join our other interval to this one with the U symbol that stands for union. And our other interval starts at 3. And because we're including 3 in our solution, we use a square bracket. So open circle, you use a parenthesis. Closed circle, you use a square bracket. And then the other part of this interval is we're going all the way to positive infinity. And with infinity symbols, you always use parentheses. You never use square brackets. Okay, we're going to look at a couple more examples. So example 3. We've got negative 4x plus 1 is greater than or equal to 9, or 5x plus 3 is less than or equal to negative 12. All right, let's solve each one of these inequalities individually. So the first one, subtract 1 from both sides. Get negative 4x is greater than or equal to 8. Divide both sides by negative 4 to get x by itself. And because we divided by a negative, we've got to flip the sign. And 8 divided by negative 4 is negative 2. Solve the other inequality. Subtract 3 from both sides. Negative 12 minus 3 is negative 15. Divide both sides by 5 to get x by itself. We get x is less than or equal to negative 3. So we ended up with a negative number, but we did not divide by a negative number. So our sign doesn't flip here. Okay, let's draw our number line. Now make sure that you're putting the numbers on the number line in the correct order. When you have negative numbers, the larger negative numbers are further to the left. So our number line is going to have a closed circle at negative 3 and a closed circle at negative 2 in that order. And it's closed circles on both of them because we have less than or equal to symbols in both of our inequalities.
Oh, okay. I was just thinking about something.
Okay, so when we shade our line, if we look at our inequalities, we've got x is less than or equal to -3. So that's all the numbers to the left of -3, all the way out to -infinity. And then we have x is less than or equal to -2. So that's all the numbers to the left of -2, all the way out to positive infinity. Negative, thank you, infinity. So really, on our number line, we could have left off this -3 because this x is less than or equal to -2 kind of overlaps.
The only time you would want to put the actual numbers when they're both going opposite directions.
Yeah. Which it doesn't matter that it's there. It's not wrong that it's there. Just be careful when you're now going to write your interval notation. We can basically ignore this -3. So when we write our interval, our solution is all the numbers from -infinity up to -2, including -2. So we use a square bracket. So the -3 is still included in this interval. There's just no need to write two different intervals for this when you can write it as one. One more example. This is example 4. -2x plus 5 is greater than or equal to 11, or 4x minus 7 is greater than or equal to -27. So let's solve these inequalities. And the first one, we're going to subtract 5 from both sides. And then divide both sides by -2. Because we divide by a negative, don't forget your sign flips. We get x is less than or equal to -3. The second one, 4x minus 7 is greater than or equal to -27. Add 7 to both sides. Divide both sides by 4 to get x by itself. We get x is greater than or equal to -5. Okay, now that we've solved both inequalities, we can draw our number line. Because both of our numbers are negative here, again, just be careful with the order that you put them in. The larger negative numbers are further left on a number line. So we've got closed circle at -5, closed circle at -3. Closed circles because we have the or equal to lines under our inequalities. Okay, let's shade. X is less than or equal to -3. So we shade all the numbers less than -3. So that's all the numbers to the left of -3 all the way out to -infinity. X is greater than or equal to -5. So our solution is all the numbers greater than -5 all the way out to positive infinity. So when we write our interval, when we write our solution in interval notation, what's our interval? If we are looking at this graph.
Negative infinity. -3 with the box and the square bracket.
Can we write it as 1 instead of trying to do 2?
Would you do just positive infinity?
Yep. We have our whole number line shaded here.
Oh, yeah.
All the way to -infinity and then all the way to positive infinity. So our solution is any number from -infinity to positive infinity. If you can write your solution as 1 interval, we want to do that rather than trying to use 2. -5 and -3 are still included in our interval. They're just not really a stopping point because our solution is all the numbers on the number line. So any number, any real number on the number line will solve at least one of our 2 inequalities. So it gets included in our solution.